Ladies and gentlemen, welcome to the Ryan to Ride Mechanic channel. How the heck are you doing today? Alright, today's video, we're going to be talking about an oldie but a goodie, something that's a flat ride but as tall as it can be. In this case, we're going to be talking about Ferris wheels. Let's get into it.
Now get ready, here we go.
If this is your first time here, welcome home. This is going to be your new favorite channel, I can almost guarantee it. I've got plenty of stuff to watch, so if you haven't, take a look back at that catalog and see what's already been made. I got a lot of good topics out there. Alright, today's topic, I'm not going to be talking about so much how roller coasters work. I'm going to be in the flat ride territory, one that I haven't done that's kind of a basic one. So I don't plan on this episode being too long today, but we're going to be talking about Ferris wheels. Alright, now, there's not a lot, honestly, to go off of these Ferris wheels. There's all sorts of different types, different structures, different installations, and things like that. But the basic concept is still the same. For the components-wise, you're talking about a rim, which is typically the round part that the actual cabs, gondolas, seats mount to. And you have the hub, which is the centerpiece that all the spokes of the rim meet at in the center. Now, there is also a different type. There's a rim and hub. That's a standard type of Ferris wheel. Or there is a centerless Ferris wheel, which also still kind of has a rim and a hub, but it just doesn't have the big spokes, but it's got cables. Yeah, I don't quite understand the terminology there because they all still look like the exact same thing to me. But then there's drives for this too. There's a hub-driven Ferris wheel, and there's a rim-driven Ferris wheel. For the most part, the majority of Ferris wheels you find out there are going to be rim-driven Ferris wheels. Those are ones where you have big, typically pneumatic pinch tires pushing up against the rim on the outside that are actually causing the rotation of the entire assembly. Now, there is another type, which is that hub-driven type, which you typically see at smaller fairs and stuff like that. This is typically like a traveling ride type thing, just because there's a lot less mechanics to it. But that is where the center of the hub has a big sprocket around it, and there is some other piece of equipment driving that, whether it's be off a gearbox or a simple chain, or it even could be a set of drive shafts running down the side. Advantages, disadvantages. The rim-driven ones are preferred because you're driving at the furthest point away from the center, therefore speed control can be at the utmost finest right there. Now, the ones that are driven from the center hub, you could still control the speed and everything down there, but when you have to slow it, stop it, and reverse it, and do things like that to maybe load and unload, then you've got a lot of backlash and play in those gears, in the chain, and all that stuff, which a little thousandths of an inch at the center of something that is 30 feet in diameter is going to be a lot of play out at the ends, and it might not produce the most stable loading and unloading environment. Okay, so how does a Ferris wheel work? Well, you basically get on the gondola, the car, the cab, the seat, whatever you want to call it, because there's many different variations of this, and they hit the start button and you go around and it's fun, right? Fun for some people, not for others. Honestly, the faster the Ferris wheel goes, the more fun you're going to have. If you find really slow ones, those are more just for scenic style Ferris wheels where you're just going up just to take in the view and stuff like that. There are scenic Ferris wheels that can still get your heart pumping though, depending on if you're friends with heights and if you're not. We'll visit a pretty big Ferris wheel in this one. But basically, as it turns around, it can go either clockwise or counterclockwise. The direction on these doesn't matter. The loading process is the part that matters. That's pretty much all the operator of the Ferris wheel has to deal with on a regular basis, and it's mainly for starting and stopping. So the loading process of getting in the Ferris wheel is typically not that hard. There are some which are smaller models, like an Eli Bridge model, where you have to let people on one or two at a time, get them locked into their seat, and then you send the Ferris wheel on its merry way. Or there's kinds that are more automated and they take many more people into the cab at the same time. And those models are even easier than that because the model actually doesn't slow down and stop. These are typically really, really big models, stuff that you won't find at your local amusement park. Most every model has to slow down and stop. But how do you get a Ferris wheel started? That is actually a tricky process, and anyone that's worked a Ferris wheel knows that there is a very special pattern to starting a Ferris wheel. If you come up to a Ferris wheel that's off in the morning time and you say, okay, I've got to run this. I can literally put my key in and start it. Done it many times. No big deal. Just start it up, run it around. It's like, okay, I'm done with my inspection. If you want to load people on it, now the operator has a whole different problem, is that the Ferris wheel is not made to take a heavy load.
That's what she said.
Okay, so they're not made to take a heavy load. What's that mean? If you take a Ferris wheel and look at it from the outside, as it starts to rotate, you could put people in gondola 1 and then rotate it to the next one, gondola 2, next one, gondola 3, and by the time you start getting around to the 4th and the 5th gondola, as it goes up, all that weight to one side of the wheel, the machine can't actually turn that. The drive tires will lose friction, they'll lose their tension on the rim, and the rim will actually slide backwards and the weight will simply center down at the bottom. The machine is actually not strong enough to move all of that weight on one side. So operators have to do this really tricky tensioning. If you think about it, if you think about a Ferris wheel with a whole bunch of gondolas or cabs all the way around the outside of it, what you're going to do is you're going to take your first set of people and you're going to load them into number 1. And then what you have to do is you have to rotate the Ferris wheel 180 degrees to load number 2. Okay, so now you have your weight at opposite ends. So if you stop the Ferris wheel there, the weight simply this way, it's balanced. It's like, okay, you can have 1 and whatever the other side is 180 degrees apart. It's balanced. So you're now going to go from 180 degrees, then load number 2, and now you're going to go 90 degrees, load number 3, then 180 degrees, load number 4. Then you're going to go about 45 degrees, load number 5, 180 degrees, load number 6, 90 degrees, load number 7, 180 degrees, load number 8. That is a lot to talk about. It's a lot to think of. It's a lot to process. The operators typically aren't going to just like, well, what size Ferris wheel are we running today? And we're doing this. This process is known. Manufacturers know it. They write it down. There is a loading and unloading order that they will do. The nice part is that once all the weight is in the Ferris wheel and you have it fully loaded with people, this is where the majority of people come to a Ferris wheel, because at that point you don't have to worry about the balance because the full thing is loaded. In fact, out of, let's just say, 18 cabs going around the outside, if you unload number 18, it doesn't really affect it because the machine is strong enough to hold all that weight all the way around. So you just unload 18 and then load it back again, and then start over and go to number 1, unload it, load it. 2, unload it, load it. 3, unload it, load it. Right? I like to move it. We can go into there. Sorry, had that going through my head when I said that. All right, so as you're loading and unloading, it's not a big deal throughout the day because the weight is still loaded. It's continuous. So it's not a big issue on the structure. It's not a big issue on the drive system of the Ferris wheel. Now, at the end of the day, when you're running out the line, that's when it becomes tricky in reverse. Actually, when there is no more people in line and you've cycled it its last time, you actually need to go through and start unloading the Ferris wheel in the same fashion that you loaded it first thing in the morning, because now your weight's uneven. This process gets really tricky when you're dealing with Ferris wheels that maybe don't have the best attendance. It's off in the corner of a park. There might be a line for it, there might not be a line for it. That's when they have to be very careful about how many they keep loaded out of, out of like a 18 coach Ferris wheel or 18 gondola Ferris wheel, they might only load 8 of them at a time and say we're going to keep every other one, or 9 we're going to keep, we're going to do every third one or something like that. They're trying to keep the whole wheel balanced, but there's going to be empty ones at the same time so they don't run into that off weight movement that's in there. Now, typically what they do is they spin it around one time. A lot of times operators start at whatever number they're at and just count up until they come back to that number. And then a lot of places they either go off of time or a number of cycles around to unload all the people off of it again. So you technically get to go around twice, or at least 2 times, because you'll go around a full circuit, 360 degrees, for the loading process. Then you at least will make another full circuit around at speed without interruption. That is the actual cycle of the Ferris wheel. It could be 2 times, it could be 3 times, and then you're going to go around one more time again. Could be, actually you should unload at that point, but you could actually go around again during the unloading process, because if I'm the first one in, they just ran their cycles, okay, so it ran full 1, 2, 3 times around, and the Ferris wheel comes back to a stop, and I get in cab number 1. I'm going to go around 1 time for the thing to load back up. Then the operator is going to run it for its cycle, whether it's 1, 2, 3. They could decide to stop and change directions in the middle, whatever that cycle might look like. I'm going to go through that, and then typically when they're done with their cycle, they should actually unload my gondola number 1. They should unload that first, so I will be back off of it again. If they change operators or do something, they might not know where they started or stopped, so you might actually get a extra rotation out of it at the same time. Now, some of the bigger Ferris wheels, the really big ones, they don't actually go multiple cycles simply because it takes too long. So you actually only get 1 cycle, that's all you need, but the time is massive. You actually have to leave time out of your day to actually go in there and do this part of the Ferris wheel. So we'll go over a little bit of that too. Okay, this is kind of an odd topic for me because it seems so simple. I might be leaving stuff out. Now, there's a lot to this. Anyone that's been around a lot of Ferris wheels, have been around traveling, whether it be traveling, permanent installed Ferris wheels or anything like that, there is a lot to them. So I'm going to try not to leave stuff out. But in my mind, they're so simple, I might be overlooking something that I am just like, duh. But so if you have any questions from here further, just let me know in the comments down there. I'll try to answer them for you, but I'm going to try not to skip the simple stuff. All right. As far as maintenance of these machines is concerned, most everything just boils down to greasing. Every gondola, coach, chair, seat, everything has a pivot on it that you simply just have to keep greased. There's really not much to them. You go to the center hub, which is what the most of these are, and you go to that center hub and it has a bearing inspection and greasing to be done with it. The bearing inspection can typically be done during the off-season time, stuff like that. They might have you actually loosen the bearing up and check some play side to side. Most of the time, to loosen something up fully assembled, you need a crane in place to do it. So it's not a huge thing, say like, oh yeah, just loosen the bearing and move it around. Not quite. But you can also use things like feeler gauges and measure the drop inside the bearing and things to see what the condition is of that. Also, if you pump grease into it and instantly comes out the top of the bearing, it's like, okay, that bearing's pretty worn. And then you might want to think about replacing the bearings some year coming up. So really not much to these rides. The drive system is where the majority of work is going to be, and that's going to be motors, whether they're AC, whether they're DC. You might have brush repairs to do on the inside, replace the brushes on a DC motor, turn the comm down and get some nice new brass out at the end so it's not wearing bad. Some drive service work, whatever is driving those motors as well. And then the constant one is brakes and tires. Like the tires that will turn the Ferris wheel, generally, they get worn really fast. They need to make sure they're at pressure every day. So every day it's brakes and tires. Got to make sure the brakes are applying and that the tires have enough traction on them with enough tension up against the rim to produce the driving force forward. Because if you take those tires on the rim and you back off that force, then what you used to be able to get hundreds of pounds off-centered with the thing and it would still be able to turn just fine, now you won't be able to do that, and it's going to rotate backwards on itself, and you perhaps stick people places you don't want them to be stuck. So you need to make sure to always keep the correct air pressure and tension on those tires at all times. This video is a little bit light on my side because actually When you're watching this video, I'll be on my way to Canada's Wonderland. So that'll be, when this video comes out, that'll be tomorrow. I'll be at Canada's Wonderland. Hope to have fun there. Let's look at some Ferris wheels. The first Ferris wheel we're going to look at is here in my hometown in Omaha, Nebraska. We're at the local sporting goods place called Scheels. It's a great place to go if you've ever been there. Inside, they have a full-size Ferris wheel. This is a really nice one. If you ever get a chance to go inside and ride this thing, recommend it, because how often do you get to ride a Ferris wheel inside of a department store? That's pretty interesting if you ask me. I know when we first moved out here, we rode this thing a bunch of times. This Ferris wheel was made by Eli Bridge. It has 12 seats. They can hold 3 passengers per seat, 36 people per load, with each car being able to hold a total of 510 pounds. The entire Ferris wheel can hold 6,120 pounds per cycle. This one's a 48-inch ride requirement, and it uses 4 5-horsepower drives. Its total setup dimensions are 45 feet high, 45 feet long, 30 feet wide, and the ride weighs in at 12,000 pounds. So in this shot here, we can see the center spindle of the hub as the ride rotates around it. All the spokes are connected to it, and then just outside of where the coaches connect, you can see the drive ring of the Ferris wheel as it goes around down here between the 2 sets of drives on here with the booster wheels. Now these drives are counterweighted, so they keep perfect tension against that drive ring the entire time. What you're seeing, the pneumatic lines there too, is the brake assembly. So all 4 drives have 4 independent brakes to lock up. The cabs are connected really easily on this ride with just simply 2 pins to the outside and a locking nut with a retainer on it. This is probably based off of a traveling model, or is a traveling model, so everything's pretty simple on this ride. There's another look at that center hub with bearings inside there. Let's bring this down for a stop and talk about the loading process real quick here for this particular model. So as you can see, they're getting off, and they're going to let the next set of people right back on from the other side of the queue line. Now, while they're doing this, everyone else on the ride is simply just waiting. This is just part of it. You have to wait however many coaches there are full. Once they're secured, the operator comes over there, presses a button, and then lowers the pneumatic platform in this particular one. This is a really nice feature that a lot don't have. The platform actually doubles and comes up and holds the cab straight while it's being loaded or unloaded. There is a clockwise and counterclockwise switch that operates the ride. They simply hit the start and tell it what direction to go. Once they bring it down for a stop, they can slowly maneuver it by toggling that switch left and right and essentially getting the whole Ferris wheel to crawl in one direction to align the cab to that pneumatic platform down at the bottom. Now in this particular case, there is no proximity sensors or programming or anything that makes sure the cab is aligned. This is all just done by the visual from the operator. So with the lack of excess controls on the ride, that simplifies the operation, simplifies the controls, which also drops the cost down of the ride. Now here's the loading process from a different perspective. This is behind the ride, and as you can see, the little platform comes up, and then when people go to get off, the footwell actually sits on top of the platform, making it extremely stable for people to get on and off, which is great for the people getting on and off the ride. It also makes it so much better for the ride operator not having to try to force the cab to stay straight and level the entire time. For this particular one, while the platform is in the up position, the ride is actually prevented from moving. So it's got proximity sensors at the top and bottom to know when the platform has reached its raised position and when it's reached its lowered position. So that's critical for part to its safety. If we zoom in here, we can see the proximity sensors. There's the upper position, and the upper position is now flagged. So right now the ride's being inhibited from moving. Once the pneumatic cylinder system lowers the platform back down, the lower proximity sensor will be flagged. It kills the pneumatics, prevents the pneumatics from working, from accidentally raising, and then allows the ride to operate. Lots of tools of the trade here, and air hose is a mechanic's best friend in this particular scenario. Here in Las Vegas, Nevada for our next Ferris wheel, and this one comes in at 550 feet high. That's right, I'm here at the famous High Roller. The High Roller in Las Vegas is a giant observation wheel with a diameter of 550 feet. It features 28 spherical glass-enclosed cabins, each capable of holding up to 40 passengers. The cabins are air-conditioned and they offer 360-degree views of the Las Vegas Strip and surrounding area. A full rotation on this behemoth takes 30 minutes to complete. Let's talk about some of its other characteristics. Total capacity of passengers is 1,120. Cabin weight, 44,000 pounds per cabin. Rim diameter, 469 feet. Rim assembly is made of 28 individual segments. A nice feature on this ride is that it's lit with over 2,000 LED systems of the various colors and display capabilities. The wheel weight is over 555 tons. Now, an interesting thing on this one is that the cabins themselves are mounted on the wheel's outboard rim and are rotated by electric motors to maintain a horizontal floor, which means these cabins have to have not only power to them, but they have to have feedback and sensors inside to ensure that they're always level. And I would imagine an override and emergency bypass to release the system so that cabins can auto-level themselves at the same time. At 550 feet, the scale of this ride is hard to grasp, but basically, that's my hand up against footers there. Those are some pretty big things. Work hard, play hard is an understatement on these things. The size of this ride is really hard to grasp. If you look at the people walking alongside the exit and compare it to these footers, and it's just not these 4-footers, there's more. But the size of these things are unbelievable. Definitely a mega structure. Check out this support leg that supports the center hub. This was manufactured by American Bridge Company, interestingly enough. Not Eli Bridge, but American Bridge. So it does have a center hub, and it uses steel cables, a lot of them, that all have to be tensioned, not only to support the outer ring, but to keep the ring into a perfectly round shape, because if you lose tension on those like a spoke to a bike, it will make the wheel deform and the rim will deform into a different shape. On the outside of the ring, they are mounted to the ring with giant clasps and turnbuckles down towards the bottom, allowing for some adjustment at either point of the ride. The ride moves very slow, as you can imagine, with a 30-minute round-trip cycle. Watching the ride from underneath, you can begin to see the AC motors that are down there moving the entire thing around. You see the black strip there that the wheels are on is actually a traction material to gain traction in different weather, and then there are some giant AC motors there, and then next to those is a set of compression guide wheels that hold the whole assembly straight, because the thing will move side to side, being it's just held by cables, so they hold the bottom and have to support it, so it stabilizes the entire ring and structure around. As you can see, people are loading on, and on the other side they come in and they offload on the other side. It's a very nice thing. I've actually been on this before. It's quite a feeling to be up there 550 feet in the air. It kind of makes your stomach a little uneasy to think that there's just nothing else around you. Plenty of safety, plenty of guide wheels, everything is an extremely tight precision fit, lots of slip rings all over the side. You see those rails passing by? Those are all slip rings for power communication. Internal, you got to remember the desert gets extremely hot, so it needs air conditioning, they need lighting, they need safety sensors, and they need that whole system that rights each one of the cabs to the upright position the entire time. That was an interesting thing I learned about it. I thought they were self-leveling, but not until I did this video. It's a great way to see the Strip. Tickets are a little expensive, but if you ever get the chance and you're in Las Vegas and you got a couple hours to kill, go over to the High Roller. It is a really cool experience, especially at night. It's amazing. I'm here at California Adventure. We're going to be looking at this Ferris wheel next. So let's go over and take a look at this guy. Disney's California Adventure just makes me think about, well, Disney's California Adventure. But anyways, I'm out here at the Wonder Wheel style Ferris wheel. This is the Pixar Pal-A-Round, formerly known as Mickey's Fun Wheel, formerly known as the Sun Wheel in Disney's California Adventure. This was designed and engineered by Walt Disney Imagineering, but fabricated by Intamin. This is standing at 150 feet high. This ride uses a mixture of gondolas. In fact, it uses 8 stationary gondolas placed evenly around the ride, and it uses 16 swinging gondolas, which is much different than most other Ferris wheels out there. Total gondolas is 24. The ride duration takes about 9 minutes for the entire cycle process to happen. The Wonder Wheel is a unique Ferris wheel in the fact that the 16 swinging gondolas are actually on their own independent track located inside the Ferris wheel, or the Wonder Wheel. These gondolas can swing independently of each other and uses the Wonder Wheel's natural momentum around to gain acceleration on the downward and upward strokes of the ride. Really fun experience if you're not used to it. Each side of the Pixar Pal-A-Round is supported on the hub by 4 different legs, 4 on each side, making 8 total. These legs are pretty standard to what you find holding most roller coasters up, so it makes sense to support the Pal-A-Round. Some of the anchors actually go down into the pond surrounding the ride, while the other ones touch down on the concrete in the center area where the people wait in the queue line. Pal-A-Round is actually on the front side, has a giant picture of Mickey on the outside. The center of this ride has much more going on than a normal Ferris wheel or Wonder Wheel would have because of the immense lighting package that the ride is equipped with to not only handle itself but the surrounding shows. This uses large external pneumatic inflated drive tires on the outside of the rim. Now this is pretty standard for these type of rides, and they used classic tensioning cables on the outside of the motors to set the preload tension against the rim itself. Passengers are loaded and unloaded 3 gondolas at a time, 2 swinging and 1 stationary in the center. The swinging gondolas have their own wheel carrier assemblies on top that run on the swinging rails. The stationary gondolas are mounted to the center rim, just like a standard traditional Ferris wheel would use. The clearance is set so that the swinging gondolas never interfere with the rotating stationary gondolas at the same time, and the ingenious way that the rings are set up inside of the Wonder Wheel means that the individual swinging gondolas never interfere with each other at the same time. It's an excellent use of space and saving of motion. If you've never had a chance to get on a Wonder Wheel, I highly recommend them. Looking at this gondola here, this is equipped with a magnetic braking fin underneath. In the load station, the swinging gondolas actually have eddy current brakes set up at the bottom. Now, This is necessary for when they come in, they're still swinging to prevent the guest and cast member injuries from trying to stop a swinging gondola. They basically slow it down and stop it with the eddy current brakes. Although for some reason this time around, the majority of the magnetic brakes were removed when I was there. I could only find 1 or 2 gondolas with the brake fin at the bottom still attached for some reason. Not sure why that was, because they used to all have them on there. When all is said and done, the Pixar Pal-A-Round is pretty impressive to go on. It's also a fun little ride not to miss. I highly recommend if you're ever in Disney's California Adventure. If someone suggests passing up the Pixar Pal-A-Round and going on a ride that might be a higher thrill environment, I would suggest going on it because it gives you a little more thrill than most people would think. Especially if people aren't used to heights. Well, did you enjoy yourself today? Did you enjoy just going around this video with me? See what I did there? I know. Alright, make sure if you haven't by now, you like, subscribe, do all that stuff downstairs. It does help me out. I do appreciate it. Also, if you want to contact me, you can either just message me down below or you could email me at ryantheridemechanic@yahoo.com. That's all one word together, ryantheridemechanic@yahoo.com. And I try to get back to people as much as I can, but I get busy just as much as everybody else does. Okay, most Ferris wheels don't have these, but please, stay off the air gates.